Atomic structure. From our chapter in matter, we learned that an element is matter that is composed of one type of atom. This is the smallest piece of matter that still retains the property of the element. For example, gold is only composed of only gold atoms, and hydrogen is composed of only hydrogen atoms. In this chapter, you will learn that each element is assigned a chemical symbol, which is one or two letters. The first letter is uppercase, while the second letter, if there is a second letter, is lowercase. For example, oxygen is represented as a capital O. Aluminum is represented as capital A, lowercase l. Copper represented as capital C, lowercase u. For some elements, the symbol is the first letter of the element's name. For other elements, the symbol is the first letter of the name plus another letter from its name. Some symbols are derived from Latin, while others are named to honor scientists, places, or for their properties. Regardless of the origin of the name, scientists derive this international system for convenience. It is much easier to write capital H for hydrogen, O for oxygen in H2O instead of writing out dihydrogen oxide, which is water. Because scientists worldwide use this system, everyone understands what the symbols mean. This atomic model helps you picture an atom. Protons and neutrons stick together to form the center of an atom called the nucleus. The nucleus has a net positive charge because protons are positive and neutrons are neutral or have zero charge. Electrons, which have a negative charge, surround the nucleus in what is called an electron cloud. But these electrons move so fast that no one can pinpoint their exact location. The model you see here is called a Bohr's model, and this is not the model that is used in current science right now, but it does help us picture where everything is placed for the atom. Moving from the Bohr's model over time, the atomic model has changed, and where that first model was established by a scientist called Niels Bohr, who hypothesized that electrons traveled in fixed orbits around the atom's nucleus, the current atomic model is called the electron cloud model. And this shows that electrons do not follow fixed orbits, but tend to occur more frequently in certain areas or levels around the nucleus at any given time. The electron cloud is 100,000 times larger than the diameter of the nucleus. However, each electron in the cloud is much smaller than a single proton. Electrons closest to the nucleus have low energy, while electrons farther away from the nucleus have higher energy. Now, electrons will fill energy levels from the inner levels or those closer to the nucleus, and then they'll start moving out to the outer levels. The first energy level can hold a maximum of 2 electrons. The second energy level can hold a maximum of 8 electrons. The third energy level holds 18, and in the fourth energy level can hold up to 32 electrons. Note, though, any outer energy level can only hold 8 electrons. And we'll talk about this more as the chapter and in further chapters. But while the outer energy level can hold a maximum of 8, this does not include hydrogen and helium, which can only hold a maximum of 2 electrons. And that is because they only have one energy level, that first one. So you notice it only can hold a maximum of 2. Okay, it's time to show what you know.